Welcome to the last video on dimensional analysis, and this one is focusing on density. Density can be thought of actually as just another conversion factor, but we'll delve a little bit deeper into density than just having it be a conversion factor. Density is how much stuff, how much is in something. If we think about a rock versus a feather, right? So a rock has much more density than a feather. We also could talk about oil and water, and oil floats on water, so it has a lower density than water. So the definition of density is mass per unit volume. All solids, liquids, and gases have a density. To calculate the density, we're going to divide the mass of a substance by its volume. So the formula is density equals mass over volume. Density is also a conversion factor. So you can remember that density equals mass over volume, or we can just look at the units. What is the density of a sample of liquid bromine that has a mass of 586 grams and a volume of 188 milliliters? You take the grams and you divide by the milliliters and you do the math. And so this answer is 3.1170, and the units are grams per milliliter. And now if we look at significant figures, this has 3 and this has 3. So our final answer will have to have 3. And so our final answer will be 3.12 grams per mil. If the density of gold is 19.3 grams per cubic centimeter, what is the volume in cubic centimeters of a 10.8 gram sample of metal? So if we go back to dimensional analysis, we think about what are we given, and we are given 10.8 grams of the metal, and we want to solve for the volume. So we want to solve for cubic centimeters. And we have a conversion factor that is 19.3 grams per cubic centimeter. And so if we set this up, in order to get centimeters on the top and to cancel my grams, I'm going to use the density here, and I'm going to put grams on the bottom, and I'm going to put cubic centimeters on the top. And the conversion is that for every 19.3 grams, there's 1 cubic centimeter. And so I'm going to do that math. So again, I take 10.8 and divide it by 19.3. And so my calculator says that the answer is 0.55958, but we look at significant figures. This has 3, 10.8 has 3, and this has 3. And so we want to report our final answer in 3. And so that would be reporting it to this place. The 5 is going to, I always round 5 up, but I know that Alex sometimes, if it's followed by an even number, it rounds down or whatever. So sorry about the confusion between these two, but I'm going to take the 5 and round it up. So that takes this and makes it 60 instead of 59. So this would be 0.560 centimeters cubed. And that's my final answer. I'm going to do one more, and I'll let you do the last one for class, as well as the next page. There's a whole bunch more problems on the next page in your notes. If 26.9 milliliters of water is displaced by a metal with a density of 7.9 grams per cubic centimeter, what is the mass of this metal? So the whole concept of being displaced is in order to sometimes find the volume of an uneven object, like an odd shape, you can actually measure a certain volume of water and then put the metal into the water, and then the amount the water moves up is the volume of your metal, because it kind of replaced the water and moved it up. So this number right here is the volume of our metal. And then we know the density of our metal, which is 7.9 grams per cubic centimeter. They want to know what is the mass of the metal. And so I want to give you an equality here that you may not know, and that is that every milliliter is actually the same as a cubic centimeter. So I will add that into my dimensional analysis. Now you can go back and look at the equation for density and solve this problem that way, but let me show you how to solve this problem using dimensional analysis. We don't even need to know the equation if we just use dimensional analysis. So here we go. What are we given? The volume right here. So we are given 26.9 milliliters. We are given that. And what are we looking for when we're all done? We want the mass. And I'm going to go ahead and assume that it's grams. So we want the mass in grams as our final answer. And so we need to put grams over here. Okay, so now I have milliliters and I need to get to grams. And I'm given this conversion factor that says 7.9 grams per cubic centimeter. But I already told you that every cubic centimeter equals a milliliter. So let's see how we're going to do this. I'm going to erase this here so that we can solve it one by one. The first thing I'm going to do is convert my milliliters into cubic centimeters. You can add this conversion anytime you're going from milliliters to cubic centimeters. So we have for every 1 milliliter, we have 1 cubic centimeters. And obviously this is not going to change the number in any way. However, it does allow us to change the units. Now I have cubic centimeters in the numerator. I need grams in the numerator. I'm going to go ahead and use the density conversion factor, which includes a unit of grams and of cubic centimeters. I'm going to put the cubic centimeters on the bottom this time, and I'm going to put grams in the top. And so that's 7.9 grams for every 1 cubic centimeter. And so now I can cancel my milliliters, cancel my cubic centimeters, and I have grams, which is what I want. And so we are in good shape. Now I just have to do the math. And so that answer is 212.51 grams. Now, if we go back and look at significant figures, we have 3 in this number and we have 2 in this number. And so we're going to need to report our final answer in 2 significant figures. And so we're going to round, and this is going to be 210 grams. And that's my final answer. Okay, I'm going to let you try this one for class. In addition, the next page has a couple more practice problems. We'll keep talking about this and other examples of density in dimensional analysis in class. See you then.